Welcome back, GED scholars and math warriors, to part 2 of the Algebra 104 series. Please remember that this is a 7-part series, and this is part 2. We drop new videos every Monday, and when we drop new videos, we also drop new worksheets. So please make sure that you visit GEDtalk.com on our resources page and on the math page as well. So in this video, we're not going to have any lessons. This video is going to share with you 6 word problems and how you can tackle them. And one way that you can tackle them is obviously figuring out the expression that can find the answer for you. Another way is to do the guess and check method, and I'll show that to you at the end of this video. If you haven't already checked out Algebra 101, 102, or 103, or Algebra 104 Part 1, please make sure to watch those videos, not only because you're going to learn the 4-step method to tackle these type of problems, but you're also going to see different things like the algebraic expressions, or how to simplify a polynomial. So you want to just make sure that you watch those videos. Once again, download the worksheets on gedtalk.com/resources. So let's go ahead and jump right in. There are twice as many queens as kings in the kingdom. If there are 24 kings and queens, how many are queens? Okay, so I'm given information that I want to pay attention to. I want to pay attention to that fact that there are twice as many queens as kings. Folks, the queens will be our Q and the kings will be our K. If there are 24 kings and queens, so the total is 24, that's important for us. So in the first line, they tell us there's twice as many queens as kings. 2K will represent the number of queens we have. We know kings are going to be our K. So it says if there are 24 kings and queens total, so I'm going to do is, because that's represented by the equal sign 24. I know queens are represented by 2K, 2 times as many kings, plus the number of kings is going to equal 24. So what do I see here? What is this called, folks? If you're not sure, please make sure you watch the Algebra 101, 102, and 103 videos in order to understand what these are. If you said they're like terms, you're absolutely right. These are like terms. So what's 2K plus K? Well, we get 3K. So we have 3K equals 24. I need to get K by itself. So what do I need to do? The opposite of what I see that's happening between the 3 and the K, which is multiplication. So I'm going to divide by 3. This will cancel it out. And then I'm going to divide on the other side by 3. Is equal to K. So if once I do that, and remember, you can use your calculator if you want. If you're like, nope, I've been studying my multiplication table like you told us to, absolutely do this in your head. So 24 divided by 3 will give us 8. So there are 8 kings in this kingdom, but the question is asking us about queens. How many are queens? So if I know that there's 24 total, now I'm going to do 24 minus the 8 kings. And 24 minus 8 is going to give us what, folks? You're right if you said 16. So the answer is C. There are 16 queens in the kingdom. So if you're looking at this problem and you're like, wait, I was always told that the variable should be what I'm looking for, that answer that I'm looking for, in which case we're asked about how many are queens. So you're thinking, okay, well, our variable should be queens, and it should just be, everything should be in relation to the queens, not the kings. And I understand what you're saying, and we're going to actually look at the equation with that in mind, that if we were to have these variables, we wouldn't have K representing the kings. We would actually have the kings as the relationship that it has based on the queens. So let's go ahead and look at this problem, and we are going to make sure that the variable we use is not K for kings, but it's going to be the Q. Remember, when we just did this problem, we had queens represented as twice the number of kings, and the K represented the kings. Well, now what we're going to do is we're going to say queens and then our kings. And we are going to establish Q for queens, and then kings is not going to be K, it's going to be the relation that kings have with queens. Well, if I know that twice as many queens are kings, that's going to tell me then that 1/2 of the number of queens will equal the number of kings. If you're like, hold on, back up. How did you get 1/2? How did you get 1/2? Okay, folks, so go back up to the problem. there are twice as many queens as kings. So if I have one king, how many queens am I going to have? If I have twice as many, 1 times 2 is 2. And the same would be true. If I had 2 kings and I have twice as many queens, how many queens would I end up having? So the fraction can grow. So 1/2 is reduced. It's as simplified as we can get. So my queens will be represented by Q. My kings will be represented as 1/2 Q. I know that the number of queens plus the number of kings is going to equal 24. I know that I have like terms on this side, on the left side of my equal sign. So Q plus 1/2 Q is going to give me 1/2 Q. Because remember, there's that invisible, that imaginary 1 in front of that Q. But we're going to remove it because remember, folks, I want you to just learn that whenever you see that variable, there's that imaginary 1 before it. So I have 1/2 Q equals 24. I want to get the Q by itself, so I need to go ahead and divide by 1 1/2 on the left to cancel that out, and I'm going to divide 24 by 1 1/2. And if you're like, I don't understand how that's even possible, it's 1 1/2, folks. Or I could write 1.5. Okay, that's the number that 24 is being divided by. So let's go ahead and pull up our calculator. So I'm going to do 24 divided by 1.5, and I get 16. If you're like, no, it's 1 1/2 as a fraction. Okay, well, we'll do it as a fraction. 24 divided by, now you got to select your second key, come down and select the fraction key, and then you're going to type 1, arrow your way over, and then we're going to do 1 over 2. Make sure you arrow out of the denominator, and then we're going to hit enter, and it's 16, folks. 1.5 is the same as writing it as a fraction as 1 1/2. So our answer is 16. And we already knew that it was 16 when we went ahead and did the problem. But the only difference the first time around is, like I said, everything was how it was in relation to the kings. So we ended up finding the number of kings first, and we had to add another step to go ahead and subtract the number of kings in order to find out how many queens did we have. As you will see in the problems that we're going to have coming up, that whenever they ask you how many are whatever, like that question, the variable that you establish should be addressing that question, that variable that you introduce. If there's anything else that is in relation to that variable, like the kings are to the queens, you're going to write it out in that way so it shows, okay, well, the number of kings in relation to the queens, my variable Q that I'm using, is 1 1/2. Let's go to the next question. The question reads, the sum of 3 consecutive numbers is 105. What is the greatest of the 3 numbers? Okay, so if there's some words in here that you are just like, I have no idea what that is, there's no problem with that. You just want to make sure that if I didn't explain it to you in this video, you went out on your own and you looked online, you looked it up in a dictionary, whatever it took to find out what those words mean. Sum means the combination. So when we see sum, about addition. Consecutive numbers mean numbers like 1, 2, and 3. They're consecutive. They each go plus 1 to get to the next number. If you saw 2, 4, 6, these are considered even consecutive numbers. If you saw 1, 3, and 5, those are going to be your odd consecutive numbers. And obviously, both of these, the list could keep going on. So the question is saying that the sum of 3 numbers, so I know a number plus another number plus another number is, which means equals 105. And then it's asking me, what is the greatest of the 3 numbers? Okay, so let's say my first number, I don't know what number it is, right? They haven't told us anything. And I'm going to just assume that it's represented by the letter X. So this next spot is going to have to be this first number, which is the letter X, plus 1, right? Because we are just doing consecutive numbers, 1, 2, 3, 4, 5, 6. We're not doing even consecutive numbers or odd consecutive numbers. So I know the second digit is going to be X, the original one, plus 1. And I'm going to put that in parentheses because I need, if I was to throw this in the calculator, I need it to understand that this is a group, they stick together. So this third number is going to be 2 plus this original number. So I'm going to do the same setup of x plus 2. So now when I look at my problem, I have x plus 1 plus x plus 2. And I notice that they're like terms. So I'm going to combine my like terms, and I have 1, 2, 3x, and then 1 plus 2 is going to give me 3. So now I have 3x plus 3 equals 105. I need to get x by itself, so I'm going to start taking away things from this left side of the expression. First, I'm going to take away the 3 by doing the opposite. So I'm going to subtract 3. It'll cancel on the left side. Subtract 3 on the right side. 105 minus 3 will give me 102. Bring down your 3x. I'm going to do the opposite of what I see, 3 times x. So it's taking care of multiplication. The opposite will be division. Divide by 3 on the left to cancel itself out. Divide by 3 on the right. 102 divided by 3. And folks, like I said, get your calculator when you need it. And I need it for this one. So 102 divided by 3 will give me 34. So x equals 34. Well, the question is asking me, what is the greatest of these three numbers? Well, if I know that x equals 34, and I'm going to write it over here on the left where we started, I know the next one is 34 plus 1, and I know these are consecutive numbers, so then I know the third number is going to be 36. What is the greatest of the three? It's 36, folks, and that's D. So let's go ahead and move on to the next question. The question reads, the ticket prices for a dodgeball game are $12 for adults and $8 for children. One day, the box office sold 200 tickets for $2,240. How many adult tickets were sold? Okay, so first and foremost, I know that they want me to figure out the number of adult tickets sold. And remember, folks, this is a multiple choice question. There's one correct answer and there's going to be 3 incorrect ones. Let's take a look at our answer choices to see if we can eliminate anything. First thing that pops out, if you didn't see it, is what letter? Yeah, D, folks. It can't be D. The number of adult tickets sold cannot be 320 when we're told up here in the problem that a total of 200 were sold. So right off the bat, before I even do anything else, I'm going to get rid of D. And obviously, when you're taking the actual exam, you can't line it out on the screen the way I did, but there is an opportunity for you to say, I don't want to select that answer because it can't happen. 200 total, and you're trying to tell me the number of adult tickets are 320? Nope. D out the window. So let's go ahead and set up our variables because we're going to need to figure out the equation to create in order to find out how many adult tickets were sold. I'm going to let A equal the number of adults. And then I have the children's tickets. Well, I know that the total number of tickets was 200, and I've already established A, so I don't want to bring in another variable into the equation. So I'm going to represent the children. The expression 200 minus A will equal the number of children tickets sold. Now that I have those established, now I need to move forward and say, okay, what other information have they given me that I can use to help me figure out the number of adult tickets sold? Well, they did tell me for the 200 tickets that they were able to get a total of $2,240. So whatever the problem is, this expression of the number of tickets times $12 for the adult, the number of children's tickets times $8, we know that the total that they made was $2,240. Okay, that kind of helps me out, right? Because at least I got rid of one set of information in the problem. In order for me to have gotten this total, I know that I needed to have multiplied the $12 times the number of adult tickets plus $8 times the number of the children's tickets. And remember, it's not 8C. We're going to write out what C stands for. And what we have is 200 tickets minus the adult tickets. That would give us the number of children's tickets. So now we see we have an equation and we need to just tackle this like pros. First thing I notice is I need to distribute the $8 to the 200 and to the 8 as well. So I'm just going to write everything down below. I'm bringing all this information down. So 12 times A plus 8 times 200 is 1600. 8 times negative 8 is negative 8A. And that's going to equal my total that I got. So let's bring that down as well. So now I notice I have like terms, right? I have this and I have this. So 12a minus 8a is going to give me what? Right, it's going to give me 4a plus the 1600 equals 2240. And we're just going to continue on because the goal is to get this A, the adult tickets, by itself. So I'm going to subtract 1600 from both sides, and I'm going to write the rest of the problem over here, you guys, on the right. So I have 4A equals, what's 2240 minus 1600? Go ahead, folks, bring up your calculator because I'm not going to spend time doing that when my calculator can take care of it for me. So 2200. And I get 640. So I'm going to write 640 on this side. We're not done yet. We need to divide by 4 on both sides. I have A equals, what's 640 divided by 4? Bring up the good old calculator. It's already set at 640 as the answer, so I'm just going to do divided by 4, enter, and we get 160. So if A equals 160, our answer is C. Okay, so let's go to the next question. So it reads, Caesar has 24 coins in his pocket. The coins are either dimes or quarters. The total value of the coins is $4.50. How many coins are dimes? Okay, so they're asking me for how many coins are dimes. So this is going to be my variable. So for this problem, it's telling us that there are 24 coins, that they are either dimes or they're quarters, and the total value is, and I know is represented by the equal sign, $4.50. How many coins are dimes? Well, I know that to get this, the total value, there was addition taking place. And so because I'm looking for dimes, I'm going to set my variable D is going to be dimes, and Q is going to be quarters. I only want to introduce one of these variables though into my equation over here, okay? I don't want anything other than one or the other. It's going to either be the D or the Q. As I'm asked about dimes, that's going to be the variable that I'm going to introduce into my expression. So 10 cents, because that's how much a dime is worth, times D plus the number of quarters times 25 cents, right, is going to give me $4.50. Well, Q for quarters, we're not going to just introduce it as quarters. I know something, the 24, as my total. So 24 coins minus however many dimes I have will tell me how many quarters I have. So I'm not going to just do 10 cents times D plus Q, because then how are you going to know what D or Q is? You just have variables there. But instead of the Q, I'm going to do 0.25 times 24 minus D equals $4.50. Now I can start solving this expression. So the first thing I need to do is I need to distribute the 0.25 with the 24 and with the D. So let's go ahead and take care of that. And folks, I'm just going to bring down my equation as I solve. So I have 0.10D. Remember, folks, grab your calculator if you need it. So let's clear the calculator. So I have 0.25 times 24, and that's going to give me 6. So I have 6, and 0.25 times negative D is going to give me negative 0.25D equals $4.50. What do I have over here? I have like terms. So let's go ahead and combine our like terms. 0.10 minus 0.25 is going to give me 0.15D. And I'm going to bring the 6 down. And if you need your calculator, folks, grab your calculator, clear your screen, and do that. Go 0.10 minus 0.25. Hit enter, and we get negative 0.15. So now I'm going to bring down the rest of the problem. So now I need to bring the 6 over. So minus 6 on the left to cancel it out, minus 6 on the right. So grab your calculator, folks. If you're like, oh my gosh, this is just too much, grab the calculator. Don't worry about it. Remember, it's a tool you will have to use, so use it. So we get negative 1.5, negative 1.5. Okay, so now I have negative 0.15D equals negative 1.5. I'm almost there, you guys. We need to get D by itself, so do the opposite of multiplication, which is division. So negative 0.15. Bring that negative sign with it. Don't leave that there, okay? So what you do on one side, you got to do on the other. So negative 0.15. And I'm definitely grabbing the calculator for this one. I already have negative 1.5 as the answer, so I'm just going to do the divide key, and then I'm going to type in negative 0.15, hit enter, and I get 10. So how many dimes are there? Well, D equals 10. So our answer is B. So folks, we're going to look at this problem, and this problem we're going to address a different way. We're going to tackle this one a little bit differently than what we've done in the past, because in this problem, we are actually going to guess and then check the answers to see if it fits the problem, the situation that we're being told about and asked about as well. Problem reads, Marcus is 10 years older than his sister Minnie. 20 years ago, Marcus was twice as old as Minnie. How old is Marcus now? Okay, so we know that all of these ages are Marcus's ages now. It's multiple choice, so I know one is correct, three are incorrect. Okay, so I know that if this is the age of Marcus now, Minnie, what is she? She is 10 years younger, right? Marcus is 10 years older. She's going to be 10 years younger. So I'm going to do minus 10. It says 20 years ago, Marcus was twice as old. Okay, so we need to just figure out which one of these ages will make sure that in the 20 years ago, we would subtract 20, right? So I'm going to do subtract 20. Marcus is going to be an age that's twice as old as Minnie. So let's go ahead and check our answer choices against what we know. So if Marcus is 25 right now, that means Minnie would be 15. 20 years ago, 25 minus 20, Marcus would be 5. And Minnie, well, 15 minus 20 years ago, Minnie wasn't even alive. So guess what? A is not our answer. Let's go to B, 30. If Marcus is 30 now, Minnie is going to be 20. 20 years ago, Marcus would have been 10, and Minnie would be born basically, or not born at all. Okay, so 10 is not twice as old as 0. So B is not my answer. C is 40. If Marcus is 40 now, that means Minnie is 30 years old. 20 years ago, Marcus would have been 20 and Minnie would have been 10. Oh, look at that. 20 is twice as old as 10. So our answer is C. Let's go ahead and finish up with this problem. It says Sally made 3 times as much money as Bethany, and Bethany made $50 more than Luke. Together, they made $950. How much money did Bethany make? Okay, let's look at our problem. It is asking me how much money does Bethany make, which tells us what? It tells us that our main variable is going to stand for what Bethany made. So I'm going to use the letter B to be Bethany. I was also told that Sally made 3 times as much as Bethany. So 3B will represent how much Sally made. And then I'm told that Bethany made $50 more than Luke. So Luke made the amount of Bethany's amount minus $50. Because if she made $50 more than him, that means he made $50 less than her. What I do know from the problem is that altogether they made $950. So I want to keep that there. So I'm going to use the column of answers as the amount Bethany made. Then I know Sally is going to be 3B, so we'll give her a column. And then I know Luke is going to be B minus 50. Bethany made $150. We know that Sally then made 3 times that amount, so 150 times 3 is going to give me 450. And then I also know that Luke made $50 less than Bethany. Well, 150 minus 50 is going to give me 100. And then what I would need to do is I need to add up 150 plus 450 plus 100 to see if that equals 950. So I'm going to pull up my calculator and I'm going to clear my screen and I'm going to say 150 plus 450 plus 100. What do I get? 700. Okay, so obviously A is not my answer. Well, let's look at B. And I'm not going to write it out. I'm just going to pull up my calculator to make it quicker for us, right? Because we're not doing the standard, let me figure out the equation. We're spending a little bit more time checking the answers against the information that was shared. So let's say Bethany makes 175. Okay, so we have 175 plus, and I'm going to use parentheses to share what Sally made. So Sally is 3 times what Bethany made. So 3 times 175. Close my parentheses. Plus, open parentheses for Luke. What is Luke's? Luke is Bethany's amount. So 175 minus 50. Close that parentheses and hit enter, and we get 825. So I know that B is not going to be my answer. Now let's move on to C. So now let's try answer C. So same concepts, we're going to use our calculator. I'm not going to write it out for us. Let's save time. So I'm going to do 200 plus open parentheses for Sally's amount. And Sally is 3 times $200, right? 3 times what Bethany made plus, and now we need to share what Luke made. And we know that for Luke, it's the amount Bethany made, $200 minus the $50. Close parentheses and hit enter. And look at that, folks. We have $950. So we know that for this problem, C is our answer. Thanks for watching, folks. Remember, if you haven't watched the other algebra videos, Algebra 101, 102, 103, even 104 Part 1, please make sure to review that information, especially if you had trouble following along in this video. If what you heard and saw in this video was helpful, please give a thumbs up and click the subscribe button so then you're notified of every time we drop a video. And of course, that means we're dropping a new worksheet. Folks, you know what you're doing. Keep your head up. You got this.